Hey everyone, thank you for joining. We'll just wait for some more seconds and just let the people trickle in. Thank you for joining wherever you are. Good evening, good morning, and welcome to our webinar. My name is Yukti, and welcome to our webinar Single Store as the best operational DB for AI. My name is Yukti, and I'll be your moderator today. One of my main jobs here at Single Store is to organize weekly AI webinars. We organize 2 or maybe 3 webinars per week. So this week we had 3. So feel free to check them out. We demonstrate data in AI use cases, different tools and technologies. Also, I post about these upcoming webinars every week on my LinkedIn, and this can also be found on our company LinkedIn page. So if any of these topics are interesting to you, please feel free to check our page out, and please feel free to connect with me on LinkedIn so you can stay on top of the loop. I'll also like to hear your feedback or ideas on any future sessions that you would like to see. So just drop in a message to anyone on the team. So if you speak of future sessions, Pranav, can you please go to the next slide? On 24th July, we have built text to SQL RAG pipeline with SingleStore and Easy Insights. The links are available to you on your screen. I will also be putting everything in the chat, so you can access it from there. The QR code will directly take you to the landing page. On 25th July, we have how SingleStore monitors tens of thousands of clusters with petabytes of data in real time. And on July 29th, we have how to build an LLM chatbot powered by agents. So if any of these topics are interesting to you, please RSVP right now, and I hope to see you all there. So coming back to today's topic, you're welcome to participate in the discussion throughout the session using the Zoom Q&A button, which is present at the bottom of your console. So we also have an internal mission statement to try to answer 100% of the audience questions, even if that means following up with people afterwards via email. Just make sure to ask away your question, no matter what it is. You can also email us at team@singlestore.com. We will take up your questions, and our team will definitely reach out to you. Moving on, I'll actually like you all to have a dynamic experience during this webinar. So feel free to try out SingleStore notebooks. Anyone who tries it out today will be entered for a chance to win either branded new AirPods or Meta's new Ray-Ban LLM smart glasses. It's absolutely the winner's choice. Simply click the link that's present on your screen. It will also be put in the chat, and just log in. You may know that SingleStore has had a free trial offer for many years, but just in the past few weeks, we have also announced a new free share tier, which we might talk about a bit later today. You might have noticed that we also have a new auto RSVP to our future AI webinars options on our website, which is displayed on any landing page if you visit. So there's now a checkbox to auto register, which will automatically add future upcoming Zooms to your calendar, which you obviously don't need to attend and join each webinar live. But this is just an option for those who have requested to automatically receive the video recordings and GitHub links that are useful for the session. You can try the demo for this particular webinar in real time as well. I will be putting Pranav's code as well in the chat today. So moving on, allow me to announce today's amazing speaker. We have the real SingleStore expert joining us today. We have Pranav, who is a senior product manager here at SingleStore. So I think we're very happy to have you here. We're all set to go. Pranav, the floor is now yours. Thanks for joining.
Thanks, Yukti. Should become a radio host. That was very good. Hey, everyone. I'm going to talk about why attention at the data layer is all you need. And some of you might know this title at the famous Google paper on attention. Attention is all you need. It's a play on words there. And I'm going to talk about why we've struggled to see very many AI experiences and chatbots and, co-pilots that have, emerged in the last 18 months. If I look back, my stack hasn't changed so much. It's still, I use Copilots when I write some code. It's not gotten dramatically better. I use GPT-4 through ChatGPT. I use Sonnet 3.5 sometimes. But I wish my bank had a chatbot that means I could never talk to anybody in customer service. I wish my airlines had a very strong Copilot that can tell me where to go on the cheapest route, and incorporate my holidays and my leave situation. I really, really do wish there were more co-pilots out there. And I think part of the problem is most enterprises are a hot mess of a lot of different data solutions. Apps are powered by operational databases, and these are the MySQLs, the Postgreses of the world. These handle your transactional read writes, your high concurrency workloads. That's not enough. There's often apps serve third-party data that's in JSON format. You'd often add a JSON store. You want to make your apps fast, so you'd add a caching layer, often Redis, to make it very, very speedy. You want to do some kind of search on some data, and you would add, an Elastic or some kind of search workload. You want to bring in streaming data, whether that's IoT or streaming data. You would bring that in, and into the operational store. And the last thing is eventually all this data hits your data warehouse, your oftentimes Snowflake, on top of which you run ad hoc analysis or insights. You're telling me when enterprises look like this, we're supposed to add AI somehow to these applications? Well, most of you might be thinking, Pranav, you're making it a lot harder than it actually seems. It's actually very, very simple. All you need is something called a vector store, a vector DB. Get a Pinecone, get a Milvus, get a Qdrant, just pip install them, create embeddings of all of your data, store them in your vector store, and then use LLMs to, run some kind of vector search to provide the latest data or the most relevant data to the LLMs. Very simple. I'm done with my webinar. Thank you so much for joining. Well, I think this is partly the reason why we've seen very, very simple prototypes. And I really do mean that. The data that you want to serve through these copilots, through these AI applications, don't live in the vector store. In fact, they never will live in the vector store. They will live across the lakehouse, when you have your historical data and you want to provide, insights based on your historical data and predict the future. They'll often live in your document store while you run full text search. They'll often live in your actual transactional store where your MySQL or your Postgres, on top of which you can retrieve function calling. So you have all of this data that lives in separate places, that needs to live in separate places. It needs to be relational. It needs to be able to scale like the lakehouse. So you're not going to move it out of there, but you're going to have to retrieve all of this data and stitch it at the application level. What you're essentially going to do here when you stitch all of this at the application level is rebuild a query processing engine that we have at SingleStore, or most databases have. This query processing engine that takes almost a decade to build and perfect. And this is just on the retrieval side of RAG. We're not talking about agentic apps that are going to, create data or create transactions. It's still in the retrieval bits. See, stitching things at the application level isn't fun. First, it's very, very hard to prototype and iterate and debug. What I mean by that is when there are sources of hallucinations or high latency, it's very hard to figure out, okay, which one of my 4 retrieval methods is causing the problem? How do I change the weightage of each one in my RAG and provide a composite, weighted score? And as a result, this often leads to inaccurate bots and inaccurate and very slow copilots and experiences. The other thing is it's very hard to keep data consistent across all of these systems. It's not just that you have 4 systems, it's you have the same data or variations of the same data across these 4 systems, and you have to run manual ETL or pipelines or manual processes to ensure that the data is there is sanity between the data between the sources. The other thing is it's very hard to ensure governance of it. You're not just ensuring governance at each database level. So like what I mean by governance is Yukti's data can only be accessed by Yukti's chatbot. And that is going to be key for what we call personalized AI experiences going forward. Very, very important and very hard to get right when you have to ensure governance at each individual level and then stitch it all together at the application level. The last thing is it's very hard to obtain full context. What I mean by full context is leveraging historical, real-time, data from your knowledge graph, data from your graph DB, data from your document DB, and join all of these things to get very, very accurate responses. Things like I can ask my chatbot, so where was I? How much did I spend on travel over the last 6 months? How much have I spent on flights last year? How much did my trip to London cost? This is data that doesn't just live in one, OLTP store. It lives across maybe some images where you have receipts or, location data. So it's very hard to stitch all of that together and obtain full context from data sources. I've always thought about this, and it says, wouldn't it be nice if there was one single query interface for which you can just retrieve all data in whatever formats you want. You want to retrieve your vector search, you can just run, a simple vector search query. You want to write some SQL for more OLAP type queries, you can do that. You want to do a graph, you can write a graph query. So you can retrieve all sorts of your data with different retrieval techniques. You can store your LLM state, your user questions, your history, their feedback back into this database, and in real time improve the quality of your LLMs with re-ranking, reinforcement learning. You can fine-tune the results. Well, I think to build intelligent applications, your models need that operational data layer. And that is that operational data layer that can do the things that I mentioned in the first slide, which is retrieve your data, store LLM state, and use all of that in real time to improve the quality of its responses. And I want to talk about how, the Lakehouse has emerged as the universal sort of truth for cold data. Whether that's your structured, semi-structured, unstructured, you can store all of that in your Lakehouse and retrieve it, train models, fine-tune them, run ad hoc reports. What you can't do with this consolidation of the Lakehouse is actually serve your applications. You can train your models and you can get it ready and you can run ad hoc reports, but you can't serve your end user facing applications at massive scale. But just as we saw this consolidation on the Lakehouse, I'm very, very optimistic that we will see the same consolidation on that real-time operational data layer. And this will do things like store your LLM context, responses history, knowledge retrieval, real-time analytics, allow you to do transactions. With that, you can build agentic apps and you can get full observability on the sanity of your LLM and your ML pipeline. Let's talk about the requirements of this data layer. I'm first is this notion of high concurrency, low latency queries. To be end user facing, lots of users are going to have to log in and use the application. So high concurrency is a must, and no one's going to wait 30 seconds to get a response back. That is table stakes. So a common workload here is, multi-tenancy customization per user. So when Yukti signs in and logs into her chatbot, it knows everything about Yukti, her last 30 days of interaction, what document she has knowledge to. And when I log into it, it's completely separate. But I also think we'll see new workloads that couldn't exist before. This is something I'm very excited about. And think of it as in a traditional BI workload case when right now we have one, analyst running one hypothesis at a time. With AI, what we can do is for one question to solve, we can spin up hundreds of different agents running hundreds of different hypotheses at the same time, validating it and drawing to a conclusion. So AI is going to require concurrency of an order of magnitude that we don't know today. For every human, there might be hundreds and millions or thousands of these agents that can be spun up querying data at the same time. That's very, very important. And I think that's going to be shaping how these agentic frameworks work in the future. Second thing is what I call true hybrid search on all your multimodal data. You can store your structured, unstructured, semi-structured data, and you can retrieve it with keyword-based search, full text search, graph queries, relational data. A workload I like to think, I was just at the AI and Big Data Expo in San Jose, was, hey, how much did I spend on my trip to San Jose for this conference? Can I just claim it? That's going to pull in data from my receipts, pictures from my receipts, data from, my bank statements, maybe my airline booking, kind of just take care of it. And the last thing, and this is key, which is it needs to fit into your enterprise stack. And I've identified, three main areas. One is real-time events. People are going to want to ask questions of the now. Hey, how much, hey, what was my last transaction? And it could be the Starbucks I bought 4 minutes ago or 3 seconds ago, for example. The integration with the Lakehouse is going to be key, where Iceberg is the, emerging sort of winner there. And that's going to be what serves the cold data, and being able to seamlessly merge hot and cold data through a single query layer is going to be very important. And then the last thing is the enterprise level security and governance. The question I like to think about here is, do you trust your LLMs or your agents to go and delete data in your multi-database system? It probably will need to. Would you trust it right now? And I think that is the importance of understanding the magnitude of where we need to head here. So let's talk about a bit about SingleStore. Sorry to bore everybody here, but I want to talk about why some of the most intelligent apps are built on SingleStore. Very quickly, who we are. We are, we've raised 412 million over the last almost 12 years. We have evolved a lot from an in-memory database to a three-tier architecture database that can do transactional, analytical, and search workloads in a single query interface. And we're powering some of the biggest customers across, Goldman Sachs, Hulu, Uber, as well as some of the most innovative startups, which I want to talk about as well. So very, very excited about where we are, and we think we're uniquely poised to be this operational data layer for AI. So this is briefly what SingleStore is. We're built for multimodal data. We're very, very good at handling your Kafka streams, your CDC workloads from your relational stores, your documents, your unstructured data, your vectors. We've got one of the best performances on JSON data in terms of analytical queries. That's a common pain and a common workload we love. You can store all of this in SingleStore. We have some great connectors with LM providers. Bedrock and SageMaker are some of our closest partners. You can pair us really well with the Iceberg community, and we are built for intelligent applications. These are customer-facing apps, behavioral analytics, video surveillance, website analytics, and what we really provide them is a single query interface for your upserts, your inserts, your deletes, your OLAP queries, your search, and give them a sub-millisecond response times. So this is the single query layer that can handle your transactional workloads, your analytical workloads, and your search workloads. And they all come together really, really well. And they're, it's this combination of all of them that we think is the unique data requirements for building AI applications. And some of our largest customers, LiveRamp, 6sense, and a big bank, are improving their current workloads to add Gen AI. So we're seeing two types of customers right now. One is, I'm an existing customer of SingleStore. I was using you for fast analytics and transactions, operational analytics, and serving my end user-facing applications. How do I add hybrid search to make my application better? LiveRamp's a great example where they provide very, very fast identity resolution for targeted ads that's entirely powered by SingleStore. And they are able to provide better recommendations and identity resolution by doing vector search. So it's meaning-based search, rather than just the analytical query. So it's the combination of two, and they've massively improved their recommendations here. 6sense is another one where they had built an internal chatbot, and that chatbot was just serving internal developers. I was using full text search initially on SingleStore. They've moved that to our hybrid search, and again, very, very interesting what their developers have said about how many hours SingleStore's chatbot for 6sense has saved them. And the tier one bank has gone from this notion of just simple analytics to being able to talk to your data, ask it complex questions, and then derive the responses. The interesting thing as well is it's not just these big names. Hundreds of AI startups are born on SingleStore, and I want to tell the story of a couple of them. Dataloop started using SingleStore almost 3 years ago in its earliest incubation stage. They're very closely partnered with NVIDIA, and it's one of the most prominent data platforms for AI that are emerging. Lumana is another fantastic example. They came to us in their pre-seed round, so they were really incubated on us, and they just closed their Series A. They do video surveillance on real-time data, and you can ask it questions like very sophisticated questions. Very, very cool product. Thorn is one that's very close to our hearts. It's a nonprofit from Ashton Kutcher, and this nonprofit helps reduce child trafficking and prevent child trafficking by doing face matching online. And again, built entirely on SingleStore. We were able to provide them, very good support from our professional services and our customer engineering teams, as well as a one database solution for every part of their application. This is something that's very exciting to these early stage companies because we can dramatically improve their experience. Instead of having to use a Mongo, an Elastic, and an RDS, it is one single store, one source of data, no data engineering, build your application and move on. And I want to talk about a quick demo now. And I want to first show you the architecture of this demo and then show you the demo a little bit. We built a very sophisticated e-commerce website, what I sort of imagine the future of e-commerce to look like. And this has some recommendations. It has really good search. And on that same, corpus of data on SingleStore, I can run transactional workloads. There are only sort of three components of this. It took one of our growth engineers about roughly 2 to 3 weeks to build, and that was because SingleStore provided them a single query interface, no ETL, build with your single query interface and move on. And we have a great connector with Vercel as well, so it made the deployment of the app very simple. So let's go into the application. It's a publicly available link, and it is available at sorry, let me just pull up the link. 1 second. I'm going to send you. You can also send this. It's called SingleStore-eStore. And I want to get, let me just put this in the chat if it's easy for me. Give me a second. Okay, never mind. You can help me with that. I want to talk about what we're trying to convey here a bit. I look at, I'm a pretty avid online shopper, almost borderline concerning, but the way I typically search for products and come across products is something like this on the right, where it's each category and then I look into it and then great, when I like a particular product, I can click on it and see, this is a interesting product that is available in X many sizes, and I can buy it. Very, very basic stuff. Nothing too fancy about it. I think we can reimagine that searching experience for products all together with SingleStore. And I want to talk to you about how we can do that. First is I can ask it simple questions like I want to buy blue jeans for the spring. And as a result of our hybrid search, you can see all of our results are blue jeans. And if I click on them, I can see great, it's all vector and it's all blue jeans. And I click on it, I can see, oh, it's actually really good results because they're the most comfortable during, spring and fall when the weather is mild. So how we do this is with our hybrid search capabilities, we're running a vector search against the image, the description of the image, as well as a full text search against the description of the image. And it is this weighted hybrid search. This weighted hybrid search allows us to get very accurate results and narrow down things like this. So that's one part of the SingleStore search capabilities. But you're not just storing, vectors and the text in SingleStore. You're storing all components of the application on SingleStore. And as a result, you can use function calling on GPT-4 and other models to ask even more targeted questions, like I want to buy blue jeans for the spring in large. And now you will see all my results are available in my size. Great. Let's take that a step further. I want to buy blue jeans for the spring in large between 150 and 200. Now you will see all results being exactly within my price range between 150 and 200. They're all available in the large. And for anyone, I can click on it and see, okay, this was how the last month's sales looked like. Great. And I can see, it's within my price range. I can see it's from spring and I can buy. This is very, very unique to SingleStore, and it makes function calling from your LLMs, right? Your GPT-4o very, very powerful. What you're doing is extracting the metadata filters from the question. So I asked the question, blue jeans, spring, medium, 150 and 200. What it did was using function calling, extract blue, the color, it extracted my price range, it extracted the size I required. And in the hybrid search query, it interfaced with all of these metadata filters to ensure that I was seeing products within my price range, the size was actually available, um, and the results are very, very accurate. So doing function calling with SingleStore can really drive down your hallucinations because all of the data lives in SingleStore, and you can write, a single SQL query or a Chi query, which I'm going to show you, a Mongo query, um, and with function calling, extract the parameters for it. So this is the query powering that search. It's just one SQL query. You can also write this in our Chi Mongo interface. And notice how quickly the application worked. We're running this application on 100 million rows of data. So it's not a small data set. It's a lot of products, a lot of orders. And in this hybrid search query, I can extract, like I said, things like product size, like color, like price, and write a single query and create a weighted score and return the results. And these queries run in milliseconds in SingleStore, just in 420 milliseconds. And we can serve this across high concurrency. So all your end users get, responses of this performance. Um, and it's actually very easy to write these queries. Like it's instead of trying to stitch all of these at the application level where you're going to do some function calling to your OLTP store, you're going to do some function calling to your Lakehouse, perhaps, something to your Elastic, maybe something to your Mongo, and combine all of these things. One query, it runs in our engine, it's extremely performant. You can tweak the weights to deliver accuracy. So that is one workflow. The next workflow I want to talk about is the recommendations part. Recommendations have often been, in the realm of clustering and k-means clustering or some kind of clustering algorithms, and we can see that becoming from that clustering world to content-based recommendations. So the recommendation algorithm we have implemented, it's a very, very basic recommendation algorithm, but it's because I bought a particular product, these blue jeans. We're going to run a vector search against these blue jeans, see some, some similarities between other products, see what price range I really care about, and suggest products. And as a result, I'm getting products that are, again, available in my size, in my price range. And that's what I like. So end users can, this is what I mean by the next generation of intelligent applications, that end users can really benefit from better search experiences with AI and with well implemented and accurate results. So this is the hybrid search part for discovery. I just want to cover it very quickly, where I go, I want to buy blue jeans for the spring in medium between 150 and 200. It first, we create an embedding of the user query. And then we also deliver this to the LLM and request for the function calling to extract the key parameters. And we combine all this in a single query in SingleStore, which is S2 here. And that does vector search on the product image, on the description, full text search on the description, and includes metadata filters. The most accurate results possible. I want to talk about the other side of this application. This application, it's gonna involve two components. One is what the end users see, and what is like my admin side of things. On the admin side of things, I can see my sales across the last couple months. Oh, I've done really badly, and I can see what products are doing well. This is sort of the traditional dashboarding BI world. What we also see here is people wanting to ask questions and talk to their data and get, slice and dice insights without having to, redo these charts. A cool workflow I can see is like, give me a summary of my last 4 months, right? And as I can extract all of this data, run my different queries, and then deliver all of these results to the end users. So, okay, great. I've got these many orders. This is how much revenue I've gotten. These are my top selling products. This is potentially how I see the future of BI to look like, right? Again, we can deliver very accurate results here through function calling, and I'll walk you through the queries later as well. The key message here is, we need to bridge the gap of what we think AI can deliver and what we've seen so far, and the accuracy of what data you can provide your LLMs is what's blocking it. And I think SingleStore is a very, very good solution to be that operational data layer and bring all of this data in a very accurate and performant way. So I want to just quickly go through some of the code we wrote for this application. This is roughly some of the application code, and I can share this repo as well. Here we extract the color, the price, the size, the limit from the user query and define this. And how we extract this is with function calling. So we expose our query interface to the LLM and say, hey, extract all of these things from the user's question. And then when we extract all of these things, we'll pass all of these metadata filters to the get product by IDs query. And in the get product by IDs query, this is the query we eventually run, which is very similar to what I showed you there. And we set, we do a hybrid search across many different things, the vector search and the full text search components, and then put in the metadata filters that we requested for. So that's a bit of the application. I'm going to post the link for the repo. I'm not sure if you've done it yet, but we're going to post the link of the repo and the application for you to play around with it. And there's also steps for you to follow on. But yeah, I think that is the main gist of the content today. Happy to take any questions. And yeah, thank you so much for listening.
That was so amazing. We actually have a lot of questions waiting for you. So let me just pick one very long question for you. So we have one question from Tarlan. He says that I would be interested to find out the suggestions or comments on the following of the couple questions. So you might have some coming up. So do we have blueprints and recommended best practices for preparing the enterprise data for AI? Example, transforming it from legacy relational formats into graph or vector stores. Are there benchmarks that help enterprises make design decisions on top to pre-compute the AI-ready format representations versus doing the transformations on demand? So it is also followed with an example. So, but are you like okay to take up this question without the context? You seem to be on mute, Pranav.
Yeah, let me just. I'm reading the question as well. Yeah. Yes, we have blueprints and recommended practices. That's all available in Spaces. Let me just send the link, which is like singlestore.com/spaces. And that has a lot of very rich content working very closely with our customers on how they either migrated to SingleStore, what are they working on with SingleStore, what does their deployment setup look like. So that's a wealth of information. There's roughly 50 notebooks there. I would recommend spending some time there. And this is a very good question on, are there any benchmarks? I think a lot of this, this is very, very interesting. I think a lot of this depends on, firstly, your appetite for spending, number one. Number two is probably the requirements of your application. And what SingleStore can, really do is what I call transactional RAG, which is like data that is created is immediately vector searchable. So data that is created and stored in SingleStore is immediately vector searchable. So all you have to do is insert that data into SingleStore, either with a transaction or through streaming sources, with an embedding, and that is searchable. So I think that might help in this, but I don't think we have like straight benchmarking on a particular formula that will work. But yeah, that's a very good question, Tom. Thank you.
Yeah, that was an amazing question. Thank you so much, Tarlin. We had some questions regarding the SingleStore estore.com, the link that you used for the website. So even I tried to access it, doesn't seem to be public. Is there any way that people can access it?
Let me just send the link again. Is it not public? It should be public.
Yeah, I don't think so, because even I couldn't access it,
That's strange. Let me try. I think I'm just gonna send the link again. It's
Oh
definitely.
yeah, people are saying that it's public. Like some of them were able to access it. So I think.
Yeah, it's definitely public. Yeah. Okay.
Just
Any other questions?
Yeah. Okay. All right. So Patrick has put in the link here. Thank you so much, Patrick. So, okay. So it's more like it's not a question, it's more like a appreciation message from Bill Reynolds. He says that kudos to the single store team having a one source of truth queryable with SQL++ or Chi is very powerful. Carbine leverages, I believe it's your company. Carbine leverages those options in real time, Gen AI aware analytics suite. Reach out to support at carbine.com. Oh, I'm so happy that you have a positive note for us. So, yeah, definitely we'll reach out to you if you have anything. And so we also have more questions for you.
Yeah. Let me
Crispin
just take
says
let
that,
me just take one, Yuki, very quickly. I
oh,
think Don,
absolutely.
another question on what is SingleStore is a meta store maintaining the indexes of all underlying data sources in real time and provides an extraction, or does it actually cache the data from this? It actually caches the data. So you can store the data in SingleStore. What we are headed towards, and this is very interesting, maybe for you, which is on Iceberg, you will eventually be able to sort of do some sort of external table query with very good performance. But yeah, but if you want to power your end user facing applications, and with the concurrency requirements and scale that we're talking about, caching the data and storing it in SingleStore is going to be the key. Um, I'll take the other one as well. Crispin has with the hybrid search, does this can this also interface with Graph? Yes, 100%. We are actually got a couple customers doing Graph knowledge base type retrieval. Search up recursive CTEs on SingleStore. That is how people write these graph-like queries. And we're also going to be implementing syntax like Neo4j to make it very simple for you to write your graph queries. Yeah, Nay asked a question on what was the evaluation criteria. There was not much of an evaluation criteria here. I think the main point is, I'm not just saying this because I work at SingleStore, but I think I really do believe it. It's like the data brought to models is almost 95% of the difference your end application is going to make. And I think that's the main thing we want to highlight here. So I think if we built this with Cloud's latest models, it might work better, but that is marginal. And I think it is when you can set up a really sophisticated RAG environment where you know exactly what data you're bringing with high accuracy, can you deliver important results. So that's our take, and there wasn't too much involved in the model decision criteria. Could you please post the link regarding the coding framework you just mentioned? Sure. I think it's just the GitHub repo. I'll just send that again, and you can clone the environment. Best approach to ETL and query. Patrick had a question, which is like he wants to build a e-commerce app. We have CDC from your MySQL and your Mongo, and we also have something called SingleStore pipelines. SingleStore pipelines are extremely powerful distributed ways of bringing in data into SingleStore. Data lands directly into memory first, and we are be able to bring in data from Kafka, from S3, from all of the other sources very easily then. I really like the question Priyanshu answered, which is every product comes with specific use cases it's good at, then there's predecessors and successors. What would that be here? And if there is, what are the benchmarks and edges compared to other products? Very good question. We ran a benchmark recently, and I'll post the link of our vector search against PG Vector, and we're almost 100x faster than PG Vector. If I were to talk about SingleStore being a 10-year-old company, majority of our money and revenue and applications built have been in the real-time analytics, operational analytics workload, but they don't look very different from the way these AI search workloads look like. It is our indexing framework that is extremely general purpose that allows you to do very fast OLAP queries, but also very fast hybrid search queries. So that's why we've seen sort of the evolution of intelligence just being OLAP and like search and OLAP and analytics to this fuzziness of some kind of hybrid search, some kind of OLAP, and the realm we've always played and dominated is in the realm of intelligent applications, and they have changed and they have become very AI first, and that involves vector search in the current sort of context. Okay, the other question is, what about data security? Data security is, yeah, I mean, like we power tier 0 apps across tier 0 companies, and I think almost 60% of our revenue comes from Fortune 50 companies. And that is something that we are very, very proud of, and we work very hard on. We are an enterprise database of choice, and it takes a decade to build something like this. So, yeah, I'll point to some slides on our sort of posture and security. We have very important RBAC, and I will, yeah, send you a link here as well. Okay, I think that is it. Uma had a question, where's the CDC pipeline environment set? I'm not sure what you're really talking about, but I can roughly tell you that SingleStore has native CDC capabilities from a bunch of sources, so MySQL, Mongo, and we're expanding that. And that all runs, that's the easiest way to bring in data. There's also incremental support. But yeah, that is coming. That is all done as well. Yeah. Awesome. All right. I think that is it. And Rikti, let me know if there's anything else.
No, just we just announced the raffle again, and we can announce the raffle winner for this webinar as well. So thanks, Pranav, for this webinar. It looks like we don't have any more questions. That was such an amazing demo. Can you please share your screen with the slides and the raffle so that if anyone who joined late, they can still sign in and have a trial and be entered for a chance to win. So, okay. All right. Thank you so much, everyone, for joining. And this was a very amazing session that we had. And oh, I don't see the screen, Pranav. Oh, yeah, thank you. So if anyone that joined late, please feel free to sign up for the raffle using the link that's present on your screen. And I've put everything in the chat as well. Or you can scan the QR code, which will take you directly to the trial landing page. You can use Pranav's code, which I have put everything in the chat. We will also send you a follow-up email with the entire resources. So just we will so that we can announce a winner at the end of the day. I'll announce one winner right now as well. So please feel free to sign up and also check out our future AI webinars that are going to happen this week and in the next week as well. So the announcement that everyone's been waiting for today. Today's raffle winner goes to Shubhadeep Paul, who is the Assistant Vice President, AI Architect at EXL India. Congratulations and thanks for joining, sir. And if that is not you, please do not give up. Again, we are going to announce one more AirPods or Meta's Ray-Ban winner by the end of the day. For anyone who tries out today's demo, please sign up at the link that's present on your screen and we'll let the winner know via the email notification. And I want to thank Pranav for today's presentation and demo. And thanks everyone for joining. Have a great rest of the day. Take care, everyone. Bye-bye.